All right. So there are 20 students in a homeroom. How many different ways can there be chosen president? So this is the president, vice president, treasurer, and the secretary. So there are 20 students, which means any of the students could be chosen that first slot. But after the president is chosen, how many slots are left? Right. And then how many treasurers are slots left? 18 and then 17. So all you have to do really is you're going to multiply 20 times 18 times 19 times 18 times 17. And that'll tell you exactly what you want. So let's see. 20 times 19 times 18 times 17. And you get 116,280. 16,280. Yes, Marcus. Well, this is my classroom code. It's right there. 692906. Everybody cool with that? Y'all see what we did? Basically, we just did 20 times 19 times 18 times 17 because that's the slots that we had. And that's how permutations work, right? That's how permutations work. All right, probability with and or issues, and or. So there's a spinner that with 11 equal areas, numbered 1 through 11. If the spinner is spun one time, what is the probability the result will be a multiple of 3 or a multiple of 2? So what we can think about kind of like is we've got this spinner and it's got 11 equal areas. So let me see if I can. This is not going to be perfect at all, but so you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So once again, not equal, but you get the idea. Imagine they're all equal. So this is 1, 2, 4, 5, 6, 7, 8. And do you have to write this out every time? No, I just want you to visualize what's going on. And so we've got that the spinner, the question is, what is the probability that it will be a multiple of 3 or a multiple of 2? So let's see. 2 is a multiple of 2. 3 is a multiple of 2. 4 is a multiple of 2. 6 is a multiple of both. 8 is a multiple of 2. 9 is a multiple of 3. And 10 is a multiple of 2. So how many of those have we circled? 7. So it's 7 out of 11. And that's the answer. Now, what if, let me go back real quick. What if instead I ask, what's the probability that it's a multiple of 3 and a multiple of 2? Notice that would be a very different question, right? I mean, let's think about what that question is saying. If I said it's a multiple of 3 and a multiple of 2, then that would mean that I'd have to only look at those that are both multiples of 3 and 2. There's only one number that fits that description. Which one is it? 6 is it. So it'd actually be 1 out of 11. So notice the difference between or and. When you think about and, then that's that intersection we use right here, okay? So when you think about and, you think about it has to satisfy both. And if you think about or, which is the union symbol, you think about or, it could be either this one or that one. Y'all see the difference? So like or could be 2, like you said, we did 2, 3, 4, 8, 9, and even 10, right? But for and, there was only one number that satisfied both. and that was 6. Y'all see the difference? That's the difference between or and and. All right. In a class of students, the following data in the table summarizes how many students passed the test and completed the homework due the day of the test. What is the probability that the student will randomly chosen from the class passed the test or completed the homework? All right, so let's think about it. So we could actually add if I could actually add an extra row and column. And this extra row and column, I'm just going to call it total here. This is just for me. I mean, do you have to do this? No. To understand this problem, no, but this kind of helps me. So what we can see is, let's see, the total amount of students that completed the homework would be 17 in this case, right? And those that did not complete the homework would be 10. Total students that passed the test would be 18. The total amount of students that failed the test would be 9. Notice that both 10 plus 7, or 17 plus 10 rather, and 8 plus 9 are both 27. So this number should come out to be the same for both. Does that kind of make sense? And so the question asks, what is the probability that a student chosen randomly from the class, so this is from the whole class, so all 27 students, pass the test? All right, so they either passed the test, that'll be 18, or completed the homework, that'd be 17. So it would be, let's see. Student passed the test or completed the homework. So either they passed the test or they completed the homework. So passed test and completed the homework. So those. So we would want 15 plus 3 plus 2, because these are the students that either passed the test, right, or they completed the homework. So it would be, let's see, 20 over 27, I think. The key with these problems, guys, is to pay very close attention as to what questions actually being asked. And you can see they did literally what I just did, right? Found out the total was 27, and then just picked up those that had completed the homework or passed the test. Maybe we just did that one. All right, conditional probability from a table. In a class of students, the following data table summarizes how many students play an instrument or play a sport. What is the probability that a student who plays an instrument also plays a sport? Okay, so we walk through this. We've got plays an instrument. So let's see. What is the probability that a student who plays an instrument? So note, it actually is saying, given that we are playing an instrument, which student will also play a sport? So the only column we're really looking at is this one right here, which 17 students play an instrument. And if they play an instrument, those that play a sport that already play an instrument are 15. So the answer would be just 15 over 17. Once again, these problems aren't hard. You just have to pay attention to what the question's actually asking of you. In a class of 28 students, 21 are female, 5 have an A in the class. Okay, so this one, we're going to kind of make our own table here, which I think is honestly best practices here is to kind of make our own table as we go. So kind of like this. And we want totals like that. And yeah, like that. All right, so let's figure out what exactly we've got here. All right, so in a class of 28 students, so there's 28 students total. So let's just be total. 21 are female. So let's see, you got male, female. So 21 are female. There are 2 students who are female who have A in the class. So A, or it doesn't have an A. So there are 2 students who are female and have an A in the class. So that'd be right there. 2 students are female, have an A in the class. What is the probability that a student is female given that they have an A in the class? Okay. So let's see. We're told that there are 28 students total. And what we can kind of do is walk our way back through to figure out how many students there are. So we've got, let's see, 21 students are female. That means there must be 19 that don't have an A in the class. And if there are 21 students that are female, that must then mean that there are 7 students that are male. Okay. And then if we think about it, let's see. 21 are female and 5 have an A in this class. So there's 5 students that have an A in the class. So that must mean only 3 of the students are male that have an A in the class, because 3 plus 2 is 5. You'll see how I'm kind of working this backwards in a way. If there's 7 male students, that means there must be 4 that don't have an A, which if I add these 2 together, it could be 23. And once again, our way to check and make sure our tables are correct is if these add up to be 28 and they do, and these 2 add up to be 28 and they do. So now what I can say is, all right, so the question asks, what is the probability that a student is female given, no, this is not the entire class here. It's given that they have an A. So how many students have an A? 2. 5, right. How many students are female? 2. So did I actually have to fill out this table? No, you could have literally done, there are 2 students in the class. 5 have an A, 2 over 5 is the answer. All right. However, I just wanted to kind of show you how to use this, because later on, it's a good idea to kind of use it that way. But be careful and note what the question is actually asking you. You can see they did something very similar here. All right. The following table represents the highest educational attainment of all adult residents in a certain town. If the adult is chosen randomly from the town, what is the probability that they have a high school degree or some college but have no college degree? All right. So it said if an adult at random from the town, okay. So we're looking at all adults here. So we know this is going to be our total. And we're looking at those that have a high school degree or some college. So that would be these 2 guys right here, right? And, but have no college degree. So what we would do here is we would just add those 2 up. So let's see, 477 plus 51, 24. See. And then we're going to divide this by our total. Which is 0.578 because we're told to round to the nearest 1,000. So let's see, 0.578, I think I said. And that's it. Once again, not hard questions, guys. Just got to take your time, think about what the question's actually asking you. All right, now we're getting to the symbolic probability rules. When you're talking about symbolic probability, there's a few things you need to note. First of all, P of A just means the probability that event A will happen. Obviously, probability that B is going to happen is also the same thing. If you see this signature or this thing right here, this means the probability that B happens given that A has already occurred. All right, so this is a probability that B happens given that A has already occurred. This would be the probability that A happens given that B has already occurred. So given. All right. And then we've got the probability that A and, so this looks like a kind of an N. So you can think about this as and B occur. And this is the probability that A or B occurs. So let's walk through this thing and see if we can't figure this thing out. So basically, I'm going to kind of create a table just like we've been doing. I'm going to take a little small one right here. Let's see here. Trying to make this a little bit neater this time. Well, a little bit neater. All right, so this is the probability, let's say, this is the probability that B happens, the probability that B doesn't happen, this is the probability that A happens, and this is the probability that A doesn't happen. Now, we'll get into just the mechanics of it later, but and then this is, of course, your totals. So let's think about it right here. So we've got the probability that A happens is 0.64. The probability that B happens is 0.4. The probability that A and B happen, so the probability that A and B happen, so that would be here right here, is 0.356. That means that the probability, if we were to continue filling this thing out, that means that the probability that that A doesn't happen, if you think about this as being 1 because your total is going to be 1, this would be 0.36 because you have to add those up to be 1. This would be 0.6 would be the probability that B doesn't happen. This would be 0.044. And this would be, let's see, 0.356 minus 0.36, 0.64, that would be 0.3. This is why I should actually use a calculator here, probably. But anyway, it doesn't matter. But you can fill this thing out. So let's walk through this. Find the value of A and B, or A or B rather, that A or B happens. So the probability that A or B happens would be, let's see, 0.356 and then what else is this? Let's see. Subtract those real quick. Let's see, it's gonna be 4, 3, 13, 5, 2, 8. So 0.284. So the probability that A happens is 0.64. And the probability that B happens but A doesn't is 0.044. So if I put all that together, I got 0.684, which should be the answer. Now there's a different way to do this, but I just wanted to show you that the tables still work. All right. But honestly, the best way to do it is this. Basically, what you do is you take the probability that A or B happens is the probability that A happens plus the probability that B happens minus the probability that A and B both happen. Right? So, yeah. Actually, yeah, this makes a whole lot of sense. Because if we were to go back to our thing up here, basically, if you take the probability that A happens, which would be 0.64, this right here, and the probability that B happens, no, you're actually counting, if you were to add these two together, you're counting this one twice. So you need to subtract off the probability that A or B happens. So subtract this off once to count for that. All right, this is the last one. So this season, the probability that the Yankees will win a game is 0.48, and the probability that the Yankees will score 5 or more runs in a game is 0.57. All right, so what I want to do is we're really going to want to create a table for this one. Let's see if I can't make this a little bit nicer looking this time. Actually cut it in somewhat of thirds. C here's hoping. So let's see. The probability that the Yankees will win a game is 0.84. So probability that they'll win is 0.48. And the probability that the Yankees will score, so actually the probability, I guess, that they'll lose, you can think about it, is going to be 0.52, right? Because that'll be one. Probably they'll score 5 or more. So probability that they'll score 5, score something like that, is going to be 0.57. So that means the probability that they won't score is, or score 5 runs, is going to be 0.43. Totals. Now, let's see. The probability the Yankees will win and score 5 or more runs is 0.38. So that's that intersection right there, that they score and run. So that means that this will be 0.10. You can literally fill out the rest from here. You could say 0.10 minus that's going to be 0.33, and 0.38 minus 0.57 is going to be 0.19, which everything else should add up to be what you expect it to be, and it does. So the question is, what is the probability that the Yankees will lose and score fewer than 5 runs? Well, it's going to be this, right? That's the probability that they lose, and that they score fewer than 5 runs. There'll be 0.33 in this here. But yeah, that's it.